Hooray, hooray! It's the second lesson in algebra. I know, okay, maybe I'm the only one that's excited. Before we get started, I want you to go ahead and go to the painfreemath.com website and take a look at the resources that we have here. If you are a student or teacher, these resources will be helpful to you. The notes are here, and I'm just going to pull them up. I already opened it. They contain notes of the PowerPoint slides, and they help you kind of stay along with the PowerPoint as I'm going through it. Most of the things that are on the PowerPoint are already written down for you, but towards the end, this is actually your homework, and you will see here that we've got practice problems, and then I like to do what I call an answer list. So in part 1, 1 through 12, all of the answers are listed in this list. There's no extra answers, and every answer should be on here. Like there's, for instance, 2 answers that have the letter 4, or the number 4. In part 2, same thing. I'd like for you to be able to find your answer here, and if you can't find your answer, it is a possibility that I made a mistake. Not that I ever make mistakes. But if you're pretty sure that you did do the problem correctly and you can't find your answer, go ahead and shoot me off an email and I'll double check, because I certainly do make mistakes. The next thing you might be aware of is the PowerPoint. The PowerPoint that I'm going through and recording for you right now is actually downloadable. Not the recording part, but the actual PowerPoint itself. So if you were a teacher and you wanted to use this PowerPoint, you could go for it. You know, do whatever you'd like. After the first, I'm going to break this video into a few segments in order to satisfy the YouTube less than 10-minute requirement. After the first section, there's a little game here that you can play while you're waiting to go on to the next section. And with that, I do believe we will get started. Okay, the learning objectives. You've got 3. I want you to be able to define and identify what an expression and a variable is. And that's pretty much the first segue here. These first 2 bullets. Substituting numbers to replace variables in expressions and solving them. And then the last, actually, 2 recordings are going to deal with the order of operations. And we are only going to be using certain operations, just the grouping, multiply, divide, add, and subtract. We still have exponents to deal with that we'll deal with later, but this is plenty, believe me. It's going to take me forever to get through it. Okay, so go ahead and take out your notes, and let's take a look at the word variable. If we broke that up into 2 words, we would find the 2 words would be vary and able. What vary means is to change. So if something is variable, it's changeable. It changes. It's not constant. And so in math, a variable is something that varies, but we use a letter to kind of let us know that's what's going on. It's a letter that takes the place of a number, and sometimes we say it's an unknown number. So an example would be, we've got 2 variables here in this example. We've got the variable y and the variable x. And the question is, what is the value of the variable y in the equation y equals x plus 1 if x equals 5 and if x equals 10? So you can see right away from this question that x has at least 2 different answers. So that's variable, it's not constant. So let's go ahead and quickly do this problem. If x is 5 and we were to substitute 5 in for x, this would become, the equation would become y equals 5 plus 1. Now this variable of y is going to simplify to an actual number. 5 plus 1 is 6, so we would say y equals 6. So for the equation y equals x plus 1, if x is 5, y is 6. Go ahead and try letter B on your own, and I will give you a moment to try that. If x equals 10, what will y be in this case? And many of you will probably be able to do that mentally. If we go ahead and substitute in 10 for x, y equals 10 plus 1, y equals 11. And our final answer would be y equals 11. So that's not too difficult. I want to go ahead and talk a little bit about the verbs and nouns that we use in algebra. And I was using them in that last slide, you might have noticed. There's a difference between what we call an expression and an equation. I'm going to start with the equation because it's a word that you've seen since kindergarten. An equation is just a number sentence that has an equal sign. And I don't know why they call it a number sentence, but it kind of makes sense, I guess, to think about it that way. But it's basically a string of numbers that are equal to something else. An example would be x plus 8 equals 2. Another example would look something like this, perhaps. 12 minus 8, which is 4, is equal to the other side of 3 plus 1, which is 4. Both sides go ahead and simplify to 4. 4 equals 4. So that works. An expression, on the other hand, is a number sentence without an equal sign. It's just basically like a sentence fragment. So if we were to look at an example, it would be x plus 8, or 12 minus 4 plus 6 divided by 2 times 3. It doesn't have an equal sign, and in a sense, it's an incomplete sentence in a way. And a lot of times we use expressions to help us practice techniques in algebra that come in handy when we actually need to use them in equations. And that way, it's less confusing sometimes to practice a technique on an expression rather than an equation. I just want to point that out because sometimes students get confused or concerned about what an expression is. You know, they come to me with a surprised expression and ask me if they're correct about it. Is this the expression? No. I'm sorry. I'll focus. Along with expressions and equations are the verbs that we use on those nouns. Simplify. Simplify is what it sounds like it is. It's to make simpler, and we usually use the verb simplify when we're talking about an expression. So the example I have here, you simplify the expression 6 minus 5. Well, 6 minus 5 is 1. So the answer would be 1. We solve equations. Solve the equation y equals 6 minus 5. Okay, well, 6 minus 5 is 1. So y equals 1. And I can do my 1 the same way I did up here. But you can see how it's a little bit different. We've got an equal sign in our equation here. We don't have an equal sign in the equation here, or in the expression here, because it's an expression. If we use the verb evaluate, we can use it for both expressions and equations. So evaluate the expression x plus 1 if x equals 8. Well, that's kind of what we did on the page before, so we could say that evaluates to 9. We could also say evaluate the equation. Actually, we did the equation on the last slide. Evaluate the equation for x equals 8, x equals 0, and x equals 1. And now for this, I'm going to do a little table, which will come in handy when you start to graph lines. And I'm going to use this column for my x's. And I'm going to start with 8, 0, 1. So when x is 8, what is y? Well, we did that up here. 8 plus 1 is 9, so y equals 9 here. If x is equal to 0, 0 plus 1 is 1. If x is equal to 1, 1 plus 1 is 2, y would have to be 2. And that would be a way to evaluate that problem, although you won't be doing anything quite as drawn out as that. I just wanted to point out what evaluate, solve, and simplify really mean. And if we look at it more broadly, basically all three of those verbs just mean find the answer. That's all that it is. Get to the answer. They try and make it look fancy, but you know, hey, it really doesn't need to be that fancy. All right, I'm going to stop at this point so that I can upload section 1, and we will continue with the order of operations momentarily.